I'm Kate.
I'm Maddie.
Oh, and I'm Anushka.
And our drawing is about photolithography, which is basically using light to transfer a pattern. So we used a material called photoresist, which is a polymer that can either be positive or negative, and positive being where the material that's exposed to the UV light is soluble, and then negative is when the areas that are not exposed to the UV light are soluble. So in our experiment, we used positive PR, and we placed a mask on top, which is essentially like a stencil, and then we exposed it under a UV light to create the pattern. So next, we used a developer solution to remove all of the photoresist that was exposed because it was a positive PR. And then another step was to etch off all of the copper that was underneath the photoresist to remove everything that was not included as part of the pattern. And the final step was to scrub off the remaining photoresist on top of the copper that was part of the pattern, leaving us only with a pattern of small metal wires, which was the same pattern as the original mask. So this process is called a top-down approach, where material is etched or removed from a bulk existing product.
So the analogy that the artist used was a cake, and there was like cats in it. So through blocks 2 through 7, they presented the 6 steps of photolithography, using in box 2 to represent the photoresist. They used the fondant to coat the cake. And in box 3, the fondant is aligned with the airbrush stencil rather than a circuit board being aligned with a photomask. In box 4, the fondant is exposed with the airbrush paint, and box 5, the edges are developed through the removal of fondant rather than us removing the photomask from the circuit board. In 6, the airbrushed cat is etched by an icing spade right there. And in box 7, the image is stripped by the removal of the fondant, which leaves an imprint of the cat on the cake. Then our artist represented the feature size effects function and highlighted that the fact that smaller structures are better and more portable, and to do that they used cupcakes because cupcakes are lighter. As you can see, the kilograms to the grams. And finally, the weird flies that are all over the cupcakes are used to show a clean room, which in most professional photolithography labs, it's a clean room, and you're required to wear a bunny suit to prevent any dust from affecting the final image. And so to show that, she had flies, which the cat ate, and the cat got sick.
All right, so I was tasked with telling you with all the little odds and ends of some technology like this. And so all of this is, fairly useless if you don't apply it, in the real world. And so an example that we were told is oftentimes this type of technology is used to make transistors. And as this technology gets better and better, the transistors get smaller and smaller. And so there was a guy named Moore. He basically hypothesized something that became Moore's law, which is basically the law that these transistors in these compressed circuits, basically the amount of transistors that you'll be able to fit in a given space will double year after year after year. And so in order to both make sure that your thing works, as well as kind of see on the nanoscale what it looks like and the topography of it, scientists often use what is called a SEM microscope, which stands for scanning electron microscope. And so how this works is that you have a narrow beam of electrons, which you essentially shoot at your sample, which you've already pre-coated in some type of conductive material, which is oftentimes like gold or palladium or platinum. And then based on that, based on your readings of kind of which electrons bounced off, you can tell what the surface of your sample was.
Any questions? Yes.
I have a question. Okay, so one of the things you very helpfully mentioned was Moore's law, right? Where the number of transistors on a circuit doubles every 2 years. Can you think of a way that you could actually possibly represent that, and like why that would be helpful with this type of analogy?
I mean, I'm not really sure with cake. I mean, it's kind of hard with cake, but like an example that I would kind of give is like if you decided to open a bakery and you decided that baking one cake at a time was not efficient enough for you for how much batter you had and how much money you were making, so you decided to make smaller and smaller cupcakes. And so like the analogy makes sense till a point and then starts to break down, but essentially kind of like that.
But I think that's a great analogy, right? Because if you have an oven of a certain size, so you can only, bake so much of a thing possibly at a time. Exactly.
And you want to maximize
If you
your
fit
profits.
more components or more pieces into that oven, you could get something where you make more money as a result. So that's a very good analogy. Yes.
So you mentioned that the dust is very important in lithography, right? Like keeping the dust out, and that's why you do it in a clean room. Why is that in terms of, like, why is it so important in lithography as opposed to some of the other experiments that we get into?
Well, in photolithography, there was a lot of oils, and we used like a lot of liquid and UV light, and so the oils like on our fingers or the dust would go in, and when it was, I forget the word. Sorry. When it was exposed with the UV light, the fingers, like the oils from our fingers would thoroughly like affect the picture and make like deep, like dark brownish imprints on the circuit board in the photomask, which did not allow us to collect like any energy data in the end. And so the dust would have the same effect. And the funny thing is, we actually accidentally left a photo, like a circuit board out, and we came back today to find it all darkened and like almost like unnoticeable due to like the light and all the fingers that have like touched it throughout the day.